So hello, good morning, my name is Ozsvald. So I've been involved in the Python world for many years. I've been teaching and speaking at PyData's, PyCon, EuroPython, EuroSciPys for a lot of years. And I co-organise the PyData London events. So that's a meetup now, it's 1,300 people in London meeting every month talking about data science. And we grew that out of London's first PyData London conference, which we held early last year. That was the first in Europe. We had 200 people, you've got 300 people here, so this is a really nice start in Paris. I'm really happy with this. I'm also an author with O'Reilly. I published High Performance Python last year. I'm not talking on that today. I've talked loads on that for the last couple of years. If you're interested in high performance work, then you'll find lots of videos online from the previous conferences. Of course, you can get the book. And if you want to talk about Python or number or multi-core or parallel systems, I'm happy to have a talk about that today. Just come and find me afterwards. In the UK, I run a company called ModelInsight and a separate company, Mor Consulting. ModelInsight's goal is to use natural language processing and machine learning under the general idea of data science to generate intellectual property for companies using open source software. I'm exclusive as a Python user. And so we generate intellectual property for companies. YouGov, as Jean-Paul mentioned, is a large company. Often I work with smaller companies, so a couple of the examples I give here are well-funded, several-year-old growing startups. So they're small companies, you wouldn't normally have heard of them, but they're trying to transform various industries. And they're doing that with data, and the data is often bad, and that's what I'll be talking about. So that last point there, I clean data. Data science is a lovely, sexy subject. Machine learning is wonderful and fun. 80 to 95% of the time is spent cleaning up rubbish data so that you can do something with it. And I spend much of my time, much of my last 10 years, in fact, doing that. And with my current clients, the majority of the last year, just cleaning up various data sources. I think there are ways to save time there. And I want to try to make that easier for you. Out of interest, I'm not sure the distribution of academic versus industrial people, this PyData. So if you're in academia, would you put your hand up? Okay, and then if you're in industry, is that 50? Majority industry, interesting. Okay. So there's an increasing rate of growth in unstructured data available on the internet, but just data sources in general. This data is meant to be consumed by a human. Often it comes out in report form, so it'll be something that is consumed in Excel for display or pushed into, say, a PDF for consumption on devices or printouts. It's very difficult to extract knowledge from that for a machine so that you can do useful work with it. So it's hard to extract data, it's hard to parse it and turn it into something machine readable. And so it's hard to let the machine consume it in any useful way for visualization, for search, or for machine learning. But it's very, very valuable. So the company that my group are working with at the moment is called Elevate Direct. I've been with them for over a year. We are their data science department. We kind of shipped ourselves in to provide this recruitment consultancy firm. And if you'd have asked me 2 years ago if I'd have been working with consultants who do recruitment, I would have laughed at you. It seems like a silly place to work. But it turns out it's an incredibly inefficient industry with lots of humans doing a lot of drudge work with horribly formatted text documents, often in PDFs. And we could use the machine to automate this. We can use the machine to put the horrible human recruiters, the bottom feeders, out of work by automating that end of the industry to make the recruitment industry a genuinely useful place rather than the somewhat messy place that it is at the moment. So I'm very happy to help fix some of the problems in that industry. And I'll be using that for some of my examples. And then previously I've worked in e-commerce recommendation, house price modeling, so Gaussian process models to overlay kind of a rubber sheet, estimating house prices by different areas in the UK. And logistics prediction, so for the Royal Mail, CETA, Orly West, Charles de Gaulle Airport, logistic optimization for resource allocation in the past. So just that final point there, most industrial problems, they're not difficult. They're not difficult in the way that Gail was referring to earlier. In academia, often you want the best results, a tiny increase in performance. In industry, often the problems aren't that hard because they're driven by human processes. So you've got an organically grown process that a human has done for many, many years, and now you want the machine to do it. So it's not hard for a human to understand how to do it, but it's very hard to get the machine to replicate the results of the human. So it's not hard, but it's very time consuming. So how can we make it easier for ourselves? And so what kind of data can we extract? Plain text is the obvious one. If you've never done these things, they always seem easy from the outset. So even with plain text, we have language barriers. So that's binary encodings of data, be it UTF-8, UTF-16, CP1252, one of the Windows formats, plain ASCII or many others. Different platforms, different endianness, how the bytes are ordered on a disk, whether the files are broken, whether they've been badly exported. With HTML and XML, HTML renders well because browsers are really robust to bad HTML. If you try to process that with a machine, it's very hard to get it to read clean HTML. And then XML is endemic in many industries. It's very verbose, and maybe it contains the data you need. EPUB, so this is better than PDF, reflowable text for publications. Many open science papers are published in EPUB. Behind the scenes, they're HTML, so at least you can get at that content. PDFs are horrible. They're genuinely horrible. How many people process PDFs? Okay, a couple of you. Some of you have been exposed to the horrors. The rest of you see the clean text on a document and you think it's easy to extract that meaning. It turns out in PDFs, generally every character has a location where it is rendered, and maybe a sentence is rendered sequentially back to front, or maybe back to front split by columns. So you have no idea that this word here and this word here and this word and this word are connected in a sentence. You just don't know that. So your software doesn't know that, you don't know that, you have to figure that out. As a human, we have the context for that. The machine has no context. Even worse is tables in PDFs. They come out as pure gibberish, but there are projects that can help that. Images containing text, I'll give an example of that. I'm not going to touch on extracting sense from audio files, but I've got a bit of experience there if you're curious about that as well. So extracting from HTML. So I'm going to assume that you've scraped your data already. There are tools like Scrapy, SCRAPY, which are very good for getting the data off the web, or you've got an offline data collection. Then you want to parse it. Your first assumption might be that you're going to use regular expressions. There's a little joke. Bob has a problem. Bob decides to use regular expressions. Bob now has two problems. And the reason is that regular expressions, they're really hard to understand. They're write once, they're not editable. You forget how they work by the next day. So they're a very powerful way of processing data. They're really hard to debug and maintain going forwards, and they're really not intuitive to look at. As soon as you've got any complex regular expression, you're in trouble. If you search a website like Stack Overflow for regular expression phone numbers, you will find 50 answers, all in conflict. Everyone is trying to improve everybody else's, and everyone can find many counterexamples. There is no standard, simple way of doing this. So it becomes a brittle solution. Beautiful Soup. Beautiful Soup for many years was the standard for parsing HTML, particularly because it dealt with broken HTML. I don't know if Beautiful Soup is still maintained. Does anyone know if it's being maintained? Anyone? It is, yeah? Okay, right. So Beautiful Soup is maintained. It's one of the main options still, I think, for processing HTML. I have a preference now for LXML and XPath. So XPath lets you navigate in a fairly human way through the HTML. So if you are in Firefox, you're looking at a web page, you use the Firebug debugger. You can look at the underlying structure of the document object model. You can see attributes, paragraph tags, HTML blocks, lists. Inside those, you can see markup tags, so span segments with a class attribute, and then you can search on those very easily, and then you can extract, say, the text that comes on the inside of that. So that's more readable than a regular expression, and more expressive. You can do some logic in those tests as well, so you can iterate through an HTML document. That final part there is something that Gail mentioned. You need unit testing. You absolutely have to have unit testing if you're doing any document data extraction in this kind of world. Otherwise, it'll work today, you change something tomorrow, and then a week later you realize that something else is broken, and then you start going in a horrible big circle over time, trying to figure out all the things that you've broken and haven't maintained. So extracting from PDFs. So on Linux, there's PDF to text that will extract your document and give you a plain text representation of a PDF file. That's really nice and easy. PDF Miner gives you a Python interface into document processing. So you begin to look into the structure of the underlying PDF document. You can pull out character locations. And I believe PDF Miner begins to try to do some reconstruction of the underlying document. So it tries to tell you whether a paragraph blocks and tries to knit things together a little bit. So you haven't got to solve that very basic data processing problem yourself. The Apache Tika project is written in Java. This is a very well-known project for extracting data from basically any high-level human data source. So Word documents, PDF documents, HTML text, audio files, image files. It will try to wrap up a number of different processors and give you a unified interface. But it's Java. But it turns out the Genius interface, there's a couple of tutorials on the web that let you use the Python Genius interface to talk to the underlying Java tools to extract that information. And text extract is a Python re-implementation, so not Java-based, pure Python, which works pretty well as well. I've mentioned that the formatting is probably really quite horrible. Until you get into the space, you don't realize how badly PDFs are rendered internally. And part of it, I guess, is when you render it in your web browser, it takes a while to render. There's a lot of work going on in the background. And when you pull out all that plain text to your indexing program, which you're going to work from, you realize how badly laid out it is and how much work you as a human have to do. So do not go in blindly on that. You have to do things like keyword stuffing. For the CV parsing I do for my client, you end up with white keywords on a white background with someone trying to explain how wonderful they are Java. Just like back 20 years ago, people would keyword stuff on HTML to improve their Google ranking. Now, there is a project, CERMIN, for academic paper extraction. Here, they extract data from PDFs, but they try to do high-level markup. So they try to find the abstract, the title, the author list, the references at the end, section headings. So they try to provide some layer of semantic markup on top of the plain PDF. And then in the commercial space, for CV parsing, with the client I'm with, we use Sovereign as one of several CV parsers. You might think the CV parsing is a fairly solved problem. They're all rubbish. I've spent the last year trying to clean up the output of these things and to normalise them. So if you're doing any data scraping and mining for projects there, expect it to be difficult, but expect the data to be valuable once you've extracted it. And then there's a couple of tools for extracting data from PDF tables as well. And then for extracting data from images, in the past I've worked with Tesseract, an open source tool. It's wrapped up in the text extract program that I mentioned, and Apache Tika. You can do things like give it a real world image. Oh, I shouldn't stand there. Give it a real world image, it'll extract all of the characters. Tesseract tries to turn those into words. It doesn't know about sentence boundaries, so you just get blocks of lines, a bit like with PDF extraction. But if you do a bit of word improvement, you can then do things like name entity recognition, which you could then use to augment the original image with, for example, hypertext links. So you can make images clickable almost, just using open source tools like Tesseract. And then fixing badly encoding text. This happens far too frequently. This is just one of those basic things. You all need to know about FTFY, fixed that for you. So you give it a bit of text that looks like the text on the right. So that's where, for example, I think in this example, that's UTF-8 text stored as binary, but then extracted as CP1252 in Windows encoding, or vice versa. I forget which way around. That's what you get, and that's what you want. FTFY just does that for you. And you get some of that using the built-in HTML unescaping tools in Python. It can help if you know which language you're dealing with. So are you dealing with Russian language, European languages, South American languages? And so there, Google's Chromium compact language detector will guess statistically based on the text you give it, which of 80 languages you're likely to be dealing with. And that can help when you're trying to turn those kind of badly formatted bytes back into an appropriate language. Interpreting D types. So let's say now we're at another stage. We've loaded our data into pandas. So we've got the pandas tool, we've represented our data, we have columns of string D types, and we want to do something at a higher level. So dates are problematic, and the next slide will show that. If you don't know what format they're in, then you're in trouble because you probably will get it wrong, because probably, being in Europe, our data does not come in American format, month, month, day, day, year, year. And there are things like categories. We have text, male and female, but for, say, machine learning, we want numeric features. So it would be nice if we had a tool that would spot categories and fix them for us. And things like weights and measures, centimetres, inches, some kind of tool that would normalise these. As far as I know, there is no tool that will take an arbitrary pandas structure of string columns and say, oh look, that's a weights and measures column, I'm going to normalise it for you. Oh look, that's a price column, I'm going to extract the pound symbols and the euro symbols and normalise them according to some constant, and then give you a unified numeric representation. If anyone would like to write that, that would be jolly useful. I would encourage you, please write that. So mentioning data examples, on the left, we have a CSV file, days, months, years, and then some monotonically increasing value. And there I've loaded it into a data frame in pandas, having told it to parse day first true. And that's because by default, day first is false in pandas. So by default, pandas is written to parse American data, month, month, day, day. If you don't know that, your data will load in, but we'll have this really weird result. So this is 1 year's worth, yes, 1 year's worth of data with this increasing monotonic value, parsed correctly day, day, month, month. So the 1st of February, how do we have that? 11, 1, 12, 1, 13, 1. These have increasing values, but if you pass it in with the defaults, which is month, month, day, day, the first 12 days are interpreted as the months, and so it'll take that value, it'll take 1, 2 as being the 1st of February, so that becomes the next column, or the 1st of February, or the 1st of March, or the 1st of April, or the 1st of May. So the low values come increasingly across these low points here. And then after the 13th onwards, the default parser will say, well, that doesn't look like month, month, day, day. It must be day, day, month, month. And it flips it around. Having flipped it, it works. So then we get the section of monotonically increasing values. And then when it gets to the beginning of the next month, it inverts it again. So you end up with all of your data represented, but out of order. And so if you're not looking for that, you won't spot it, and then your data makes no sense. So be very aware of that. To merge two data sources, this is very common. I've got two data frames that are like an SQL join. When you merge, you need clean keys. Often in the real world, we don't have clean keys. So one thing you can do is use a tool like Fuzzy Wuzzy or Metaphone, which will try to give you a text distance measure, and you can use that to find, say, the phonetic distance between words, or do edit distances to say that I don't mind some capitalization changes. And then DataMade's dedupe is a wonderful open source tool for this. So here what it'll do is it'll read through a CSV file, like the one at the bottom, and it'll look for character edit distances between fields, and you teach it that these two fields are the same thing, so they can be deduplicated. Keep the one with the most information, get rid of the second one. But you've got 1,000 examples, some duplicated, some not. So you're teaching it the edit distances of each of the columns such that it can automatically decide that some rows can be merged together and some can be discarded and the rest will be kept. So this is a very useful tool if you're deduplicating public data. If you've got open data from government websites, this is a very common tool to use, and Google's Open Refine. What you will end up doing is normalizing the data by hand. So you need to eyeball the problem so you can solve it by hand. You will need lots of unit tests. Again, unit tests. Always use unit tests for any kind of repeatable processing platform that you're developing. And you'll do common things. So this is what I'm doing with the recruitment platform at the moment. Things like lowercasing your text. So Accenture capitalized or full caps becomes lowercase. Stripping off unnecessary white space and removing duplicate white space. Replacing patterns with an empty string. So for example, limited, you just strip off. Limited PLC, public limited company, limited the long word GmbH, Pty. Strip all of these off so you get a normalized company at the end of it that you can start to do feature comparisons with. You need decoding, so removing accents of your characters to get to a lower dimensional ASCII phase. Normalizing Unicode, that's a tiny snapshot of 50 different dash variants. Dashes are They look the same on screen. You have no idea that they're different things, but there's 50 of them. And then you can't do an ASCII compare, you can't do a string compare because there are different values in there, of course. So you have to start unifying all of these different variances and make them into one thing. And then tools like NLTK and WordNext is a relationship. It's very useful for normalizing your text. How am I doing? Oh dear. And then old and simple approaches, so rule lists, plain text. Oh my. Rule lists. Don't forget the old approaches. If you have 20,000 rules, you can of course make a Python script with 20,000 rules represented. You can iterate through them trying to match the data that you've got and mapping it to data that you want. If you've got a deployed solution, particularly a multi-language solution, maybe that's not the best solution. So with my client, they're a .NET shop, and they interoperate with my Python code using bridge tools like MySQL. So 20,000 rules get stored in MySQL, and then we use MySQL to do string matching. It works incredibly well. It's what a database is designed to do, and we have a shared data platform, so we don't have to have the languages talking directly to each other. We just share some of the logic and the data in storage engine. I have a suspicion that we are increasingly going to see tools that automate the process of normalizing our data. So here's an example I put together recently. Here, if you've got the data on the left to 53k with benefits, or pound 55,000 salary, but what you want is the integer column next to it, rather than developing the regular expressions and the parsing rules by hand, wouldn't it be nice if you said to the machine, I've got this on the left, I want this on the right, you figure out the transformation sequence. And so that's what the annotate service does. It comes up with a number of transforms based on regular expressions, string manipulations, Unicode decoding, fix this for you, all the things I've mentioned. Here I've scraped data from a job site. I took down all of the messy data columns for salaries, and then I put it through annotate, and then I graphed the result, and I didn't have to write a single regular expression. So this is really nice. It means that my iteration time is much quicker than it was before. And I think we can extend the idea of dedupe that we saw before. Dedupe is there for deduping lines inside a CSV file. The tool that I want is where I say, I've got this CSV file, and I've got this Mongo file, whatever. Another data set with a column, and I want to join on the columns. The columns are different, but I can tell you which columns map to the same thing. So which things look like the same name and the same address, the same company name. And I want to teach it what some of these joins look like, and I want it to generalize the result. So I give it 20 companies with examples of this is what a company looks like on someone's CV, and this is the company that I'm trying to normalize it to. And now for the other 20,000 companies that I know that I have, generalize some of the rules. So I have some prototypes here. I have it working on my problem. It's not ready as an open source tool at all yet, and it makes far too many assumptions. Maybe some of you have solved similar problems, and I'd love to hear your feedback on that. But anything here that helps me do less legwork by just having to spend time doing it manually, anything that automates that feels like a good thing. There are hardly any tools for visualizing new data sources. So an example is my client comes in and says, Ian, here's a CSV stick, here's some data. I'm meeting the owner of that data in an hour's time. We have to find out if we're going to buy it. So I've got less than an hour to look at it. It's probably rubbish. It's probably got a lot of nans in there. It's probably inconsistent. It will not map to my current data, and I have to make a decision about it very quickly. There are some tools for visualizing. So this is the Sato's CSV fingerprint. It tells you a little bit about your data, and of course you've got Excel and you've got other tools. We don't have rich tools yet. Maybe some of you know of rich tools that I don't know of, and I want to hear about them. I've put together a data frame visualizer that begins to work on this. So rather than using matplotlib to visualize data, which breaks on text data, instead I use Seaborn, which builds on matplotlib. Seaborn understands text. It turns it into categorical variables. So I can throw an arbitrary data frame at it, and it does things like say, oh, well, all of the name fields, they're unique, so okay, they have a value of 1 in this histogram, but it visualizes it without breaking. And then it can start to aggregate data. Also in Seaborn, I can say, well, there's a dependent variable. So in the Kaggle Titanic prediction challenge, which of my columns have a relationship with the survived or died column? And so very quickly it will take my arbitrary pandas data frame that I've not cleaned up and begin to show that some columns show no relationship easily, but other columns seem to have some kind of informative relationship against this dependent variable.
So this is a rubbish script right now. I wrote it a few weeks ago. It's the beginnings of automating this, so I get a quick view upon new data sources. I'm sure some of you have done this. Please come give me your feedback. How have you solved this problem? Or what do you need in a tool like this? What would make your life easier? Yes, I've already mentioned that I want to automate all of this. Feature extraction in general is the lifeblood for good machine learning. We do that by hand, typically. I think there are ways to automate at least some of that, to propose new features by transforming existing data sets. I don't know much about this. I do it by hand like most people. Some of you must have automated some of this. Please come and tell me how you've automated your feature extraction for text data and for numeric data. I'd just like to learn more about this field in general. So how do you get started? You have to treat data cleaning in an industrial process as more of an R&D challenge than an engineering challenge. One of the biggest challenges, so I'm giving a keynote in a couple of months, I'm surveying fellow data scientists. One of the biggest challenges for data science in industry is that the engineers look at the data scientists and assume they go through an engineering process or an R&D process. So you have to accept cleaning data is an R&D process. Your data will have missing items and it will lie. There'll be conflicting data, there'll be missing data, there'll be confounding data. It will just be a bit aggressive against you, and you have to take charge of dealing with that and fixing it. So visualizing it is the first thing you should be doing. Seaborn, which builds on matplotlib, is a very good start. The scripts that I've written will give you some ideas as to what you might do yourself, and hopefully we can improve that and make that a more useful tool for first-line data visualization. You need to break up your task into realistic milestones, break it into steps, and make sure you have lots of tests. It's not repeatable if you don't have unit tests. The notion that scikit-learn has 95% test coverage, that's incredibly powerful. You need that. How many of you in your data science, when you deploy data science, any kind of scientific solution, have better than 50% test coverage? There must be a couple, okay, a handful of you. Bad, the rest of you. You need more unit tests. Without the unit test, you can't trust your code, you can't trust it in 6 months, you can't trust it in a year, you can't trust it when a colleague comes and starts working on it. You need to use more unit tests. You need, of course, to have a gold standard. If you come from a scientific background, you understand the idea of a gold standard, where you don't use all of the gold standard when you're developing your solution. Regular engineers and programmers will not think that way. You must teach them that a gold standard is necessary. Managers almost certainly do not understand that idea. You have to teach them you need a held-out gold standard data set. There's a lot of tools out there. I am, after 15 years, still discovering new tools that I probably should have found years ago. That's partly why my appeal for help. Please tell me what I'm missing. 3 minutes? There are tools like Alchemy and DBpedia for entity recognition and sentiment analysis. So non-Python tools that exist on the web, free APIs or commercial APIs. Alchemy is really good. It's very good at named entity recognition if you're dealing with US people or companies or places. It's reasonable for European entities, and then for other languages it gets bad quite quickly. It's still, I think, the best on the market. So if you're marking up data like tweets or Facebook messages or Reuters posts, it's very good. How many people use Python 3? Okay, how many of you are on Python 2? All right, you're making your life much harder for yourselves. Go to Python 3.4, Unicode generally gets solved. All the Unicode decoding errors that you love to solve every day, they go away. And that makes your life easier. It's one less source of bugs, one less source of distraction. For me, I've realized my main tools for this kind of task are pandas and Stack Overflow, because every question I have is answered in Stack Overflow. It's just the go-to place to find out how to do the stuff you need to do. So, I'm curious about your thoughts on this, the annotate idea of automated data transform. Here's what I've got, here's what I want, you figure it out for me. I want to hear your dirty data horror stories. So I gave a keynote talking about this months ago. I've got another one coming up later this year. Learning not just my examples over 15 years, but all of your examples. That's important to make sure I'm telling the right stories and trying to give solutions through them during this keynote. So please give me your stories. If you're ever in London, we have a monthly meetup for our PyData, and then the conference should be the weekend of June the 19th. There'll be an announcement about that when we've actually got the dates definitely locked in place. We'll be looking for lots of speakers. And yeah, what's the hardest thing in data science in your team? That's, I imagine it's going to be data quality and the iteration around it, but I'm curious about your thoughts. Thank you very much.